Hi, this short video is going to concern the topic of this class, logic, and the motivation for the class, why we might be interested in studying that topic. So I'm going to start by talking about arguments. By an argument, I mean a sentence or sentences that are the premises and then a conclusion. And the point of an argument is that the successful argument, the conclusion follows from the premises, and that in a good argument. So if we look at this first argument here, we have our premise, the Earth is a sphere, and our conclusion, so Trump is president. Now, the premise is true, the Earth is a sphere, more or less, and Trump is president. But this is nonetheless not a good argument. Why? There's no connection between the truth of the premise and the truth of the conclusion. Here's another bad argument. Cygnus is a swan, so Cygnus is purple. Well, I don't know of any purple swans, so if Cygnus is a swan, it's very unlikely that Cygnus is purple, so this looks like another bad argument. In the first case, at least the premise and conclusion were true, but here we don't even have that. We have a true premise and a false conclusion. So in both cases, among other things, or an apparently true conclusion in the second case, who knows? But in both cases, certainly a connection between the premises being true and the conclusion being true is missing. Let's consider another argument. All life shares deep biological mechanisms. If life descended with modification from a common ancestor, then all life shares deep biological mechanisms. No other hypothesis explains that phenomenon as well. So, life descended with modification from a common ancestor. Now, if you took the good and bad argument quiz, you might have been troubled by this argument. You might have had trouble deciding, is it true that it's a good argument, or is it false that it's a good argument? Is it or is it not a good argument? Well, I think this is a good argument, or at least it's a fairly good argument. This sort of form is the form of this argument is called inference to the best explanation. And so we have this phenomenon, life shares deep biological mechanisms, and we have an explanation of at least a potential explanation of that phenomenon, namely life descended with modification from a common ancestor. And then we have a comparison claim saying that not only, so we have a possible explanation, and then we have a claim that that's the best explanation of the phenomenon. And all scientific theories, all major scientific theories, any big theory in physics or in biology, is supported by this sort of argument. It's an inference to the best explanation. Now, whether or not a given inference to the best explanation is any good depends upon the actual inference. You have to look and say, how well does the supposed explanation actually explain the phenomenon? Are there other phenomena that also need to be explained or not? Are there other possible explanations of these phenomena? And so those questions are, you would think about, well, 2 and 3, the premises 2 and 3 in this argument. In fact, I should just say in passing that, in fact, the claim that life shares deep, that life is descended from modification from a common ancestor, that explains lots of other things as well. So the real inference to the best explanation argument for belief in evolutionary theory is a stronger argument than the one that's displayed here, because in that case we have evolutionary theory explaining a lot more phenomena. But in any case, this form of argument, at least, is the form of argument that is relied on in all natural sciences. So if you think this is a bad argument, then you are being really skeptical about all natural sciences. That said, there is a reason to think it's a bad argument, or at least to think it's not the best form of argument that you could get. Namely, it's possible for all the premises to be true, and yet the conclusion to be false. It could happen. That possibility cannot be conclusively ruled out. Now, does that make the argument a bad argument? Not necessarily. I don't think so. But it does make it it is a way in which it's an imperfect argument. Well, let's consider then another argument. Spot is a dog, so Spot is a mammal. Now, this argument, you might think, oh, this argument is better than the previous argument. After all, no matter what, if the premise is true, then so is the conclusion. And so the link between the truth of the premise of this argument and the truth of the conclusion of this argument is stronger than in the previous argument. But this argument also seems like it is not such a good argument. In fact, I would suggest that it's a worse argument in important respects than the third argument. Why? Well, the connection, it's true that no matter what, if the premise is true, so is the conclusion. But to know that, to understand that, you need to know further facts about the relationship between being a dog and being a mammal. This one way to see that is to think, well, look, the argument, if we were to reinterpret some of the vocabulary, like mammal, if we said, oh, we took that word mammal and thought that it meant, say, purple, then we would think, oh, well, that's not a good argument, so reinterpreted. In other words, if we reinterpret non-logical vocabulary, like dog or mammal, the argument no longer, we no longer have a connection between the truth of the premises and the truth of the conclusion. And that shows that insofar as there is a connection between the truth of the premises, or premise, and truth of the conclusion, that connection depends upon specific facts about being a dog and being a mammal. Now we can express the relevant fact, namely that every dog is a mammal, and add that as a premise. And this is a much better argument than the previous argument. In both of these arguments, it's true that it's the case that if the premise or premises is true, then so is the conclusion. But in this next argument, it's also the case that no matter how you interpret the words spot and dog and mammal, if the premises come out true, so does the conclusion. And that's not true in the previous argument. If you can reinterpret the words dog and mammal to make the argument come out false. So in the previous argument, there's a strong connection given the actual meanings of these words. And in this current argument, there's a strong connection between premises and conclusion given the actual meanings. But also in this argument, but not in the previous argument, we can reinterpret a lot of the vocabulary and maintain that truth-preserving connection. And we can't in the previous argument. Reinterpretation does not preserve truth connection. And now if we consider this last argument, Opus is a penguin, every penguin is literate, so Opus is literate. Is this a good argument or a bad argument? Well, so in this case, unlike the previous case, at least one of the premises is false. It's not true that every penguin is literate. So this argument does not give us a good reason to actually believe the conclusion. But the connection between the truth of the premises and conclusion in this argument is exactly the same kind as in the previous argument. And it's that connection that we're going to be focused on in this course. In a good argument, in the sense in which we're interested in good argument, the truth of the premises bears favorably on the truth of the conclusion. And what we've just seen is, so we're focused on the connection between the premises and the conclusion. What we've just seen is that those connections come in different strengths and are explained in different ways. So we're specifically interested in the notion of validity. So what is validity? Well, it's the kind, an argument is valid, those last two arguments are valid and the others were not. So an argument needs to be truth-preserving, so if the premises are true, then so is the conclusion. But it also needs to be necessarily truth-preserving, so that no matter what, in any situation whatsoever, if the premises are true, so is the conclusion. And this should be because of the logical form of the argument and not because of the content of the argument. So if we look back at those arguments, those last two arguments, the spot is a dog and the opus is a penguin argument, we can see that they're of, in some sense, the same form. We have circle here where spot or opus occurs, in the two different arguments. We have square where dog or penguin occurs, and we have triangle where literate occurs. And so we can say that in some intuitive sense, these arguments are of the same logical form, and they're truth-preserving because they have that logical form. So what do I mean by same logical form? Well, they have the same logical vocabulary, the words like every and is and a, and they have different, the different non-logical vocabularies in the two arguments, right? The words like spot and dog and mammal, or opus and penguin and literate. So the arguments have different non-logical vocabulary, but they're of the same kind, so names, or nouns, or adjectives. And that non-logical vocabulary is arranged in the same way. And so we can actually, and what we see is that it doesn't matter how we interpret the non-logical vocabulary. And so the sort of Another way to define validity is this, that an argument is valid if and only if, for any interpretation of the non-logical vocabulary, if the premises are true on that interpretation, then so is the conclusion. And the idea then is that it's because of the form of the argument, how the words are arranged, and not the content of the argument, what specific vocabulary occurs in that argument, and how that vocabulary is interpreted. It's the form, not the content, that matters. And this is one way of trying to spell out that idea that it's the form that matters and not the content. Now, we're relying here on a distinction between logical and non-logical vocabulary, and I haven't defined that distinction, and there's some philosophical debate about what that is, or how exactly that distinction should be understood. And I'll talk about that a little bit more as the course proceeds. So in general, we're interested in validity and other logical relations like validity, which we'll talk about again as the course proceeds. And they're more specific goals, so we're going to be interested in describing logical forms, and we're going to be interested in explaining validity, and we'll see how we do that again as the course proceeds. So these goals are not trivial, reaching them. Aristotle made some progress in reaching them in the BCs. But then, and there's some developments in logic after that that are important. But the next really big step was taken by a German named Gottlob Frege in the 1860s. And now a lot of these issues are pursued in linguistics as well as in philosophy. And one of the big tools that we'll be using, and which is due substantially to Frege, is that we'll be using not English to study logical form, but we're going to have our own logical languages that are explicit in ways that English and other natural languages are not. Now, what that means explicit, I'm going to talk about in another lecture. So, okay, topic, logical relations, so things like validity, being truth-preserving due to logical form. And so what are we going to do? And so we'll be talking more about logical form and validity and other related notions. So in pursuing those goals, we're going to be doing parsing. That's what we'll be doing at the beginning of this week. That's just learning the grammar a little bit, how to break apart a sentence into its grammatical parts. And that's going to be pretty straightforward. We're going to be looking at symbolization and translation. So that's where we're going to have the logical language and the English language, and we're going to say, okay, here's a sentence of English. Can we come up with a sentence of the logical language that has the same logical form and that intuitively has the same meaning? And translation is going back the other way, from sentences of the logical language to sentences of English. A lot of your time will be spent also doing derivations. A derivation is where you're given an argument, so premises and conclusion, in the logical language, and you're asked using rules to show that, in fact, the conclusion does follow from the premises, that the argument is, in fact, a valid argument. And then we'll also be looking at truth tables and models, which are ways of talking more explicitly about truth and falsity. As we'll see in the derivation system, truth and falsity aren't explicitly part of that. And we'll talk about, and that's actually important, and it has to do with computation. I'll talk about that once we get into the derivation system. So that's sort of an introduction to the topic of the course and some of the activities that we're going to be doing. Why would we study these things? Well, we might just be interested in the structure of thought and language. We're getting at sort of some of the fundamental structural pieces of it, both how the pieces are put together and the sort of the basic pieces, and how those basic pieces, what logical vocabulary joins those more basic pieces. We're going to be hopefully able to describe in somewhat general terms good reasoning. We have sort of an intuitive sense of what reasoning is good and what reasoning is bad. This will help us to be more explicit about what reasoning is good and what reasoning is bad. Seems like that's a worthy thing to do. And hopefully that's going to actually help us to improve our actual reasoning. We'll be better at reasoning because we'll be better able to describe what reasoning is good and what reasoning is bad. And we'll also hopefully start to understand the notion of computation. I'll talk about that briefly right now. So a computer of the kind you're presumably watching this video on is a symbol processor. It doesn't use symbols of ink. It uses electronic symbols, Those are the symbols that are stored on the hard drive and in the working memory and so on, and it carries out processes on those symbols. That's computation. Well, the computer is in a certain sense stupid in this sense. It doesn't know what the symbols mean. It only knows how they're arranged. In other words, when it decides what to do with the symbols, when it decides, it's responsive to the grammar, the structure, the form of the symbols, but not their content or meaning. And since we're interested in logical form and describing logical form, we're basically interested in describing the sorts of properties that computers work on. And if the mind is a computer, as a lot of people who study psychology think it is, then we're also beginning to understand how the mind actually works in certain very fundamental ways. So those are some of the reasons why we might want to study logic and logical form. So thanks for watching, and enjoy the next video.